would you approach this question? Now, if you want to try it for yourself, I'd recommend pausing the video, quickly working it out, and coming back to see if you were correct. But if you want to see the solution, let's go for it. When I was figuring out this question, I drew two circles for myself. This is a circle that would have been present here. We know that the diameter goes from here to here and here to here. But we also know that from the information given, the 10 centimeters and the 1 centimeter, that we can draw a square inside of each circle to help us with the calculations. It's important where you place the square, however, since if it starts and stops at the exact same point that the diameter does, we can use Pythagoras' theorem to calculate the diameter. Let's label these sides as x and indicate the 1 centimeter that will be here and at the top as well. Let's talk a bit about why we can assume that the 1 centimeter they indicated here can be assumed to be 1 centimeter at the top as well. You need to remember that we are using a rectangle. We are not assuming that this is a square. If this was a square, it would have been a lot easier to calculate, but we can't assume that. So since it's a rectangle, we know that these two sides are an equal length. This part and this part would look the exact same, as well as here and here, when you take the rectangle into account. The other variable that I also took into account was this distance from here until here. Let's label that as y. We know that the blue is 1 centimeter, and we also know that this orange part at the top here and at the bottom here are 10 centimeters. We annotated basically all of the unknowns and the knowns in the sketches, but now we need to start doing calculations. Remember when I previously mentioned Pythagoras' theorem? Well, we can use it here. We know that through the Pythagoras theorem that the diameter will equal the square root of x plus the square of 10. If we look at this side and this side, this is a right angle, so we can use Pythagoras' theorem, and we work with the 10 and the x to get this equation. The reason why I made a second sketch is just so that we don't get confused between them, otherwise there would be so much drawing. But if we look at the second sketch, we can also say that the diameter equals y plus 1 plus 1, but let's add them together to say 2. 1 centimeter gives you 2 centimeters, and then adding this length from here to here, which is y. We can also see that we have the same exact value here, so we can set these equal to each other. But if we look at our sketches, we can see that the lengths y and x are actually the exact same. So we can say, but y equals 2x. So now we can substitute x into every place that y is, which is here. And from here on out, it's easy. So I'm not going to use color for this. To get rid of the square root, we will square the x plus 2, and then we're left with x squared plus 10 squared. And if we multiply this out, we get x squared plus 4x plus 4. Simplifying this even further would show that these x's cancel out. 4x is on this side, and remember this is 100 minus 4. X is 24. So we're not done yet. We only calculated x while we need the value of d. As you can see here in this formula, we only have one variable, and that variable is x. So now we only need to substitute x into here, which gives us the radius of 13 centimeters.